Hello, my name is Dylan and I'm a physics tutor and I aspire to be a professor. Welcome to another YouTube video on physics, specifically projectile motion. Let's begin. So here's the problem we're going to approach. A projectile is launched horizontally off a ledge with an initial velocity of 60 meters per second. If the height of the ledge is 3.8 meters, what is the amount of time required for the object to land? How far from the base of the ledge does the object land? And what is the height of the object after 0.6 seconds? So let's keep track of our given data. Let's see what we have. We have initial velocity is 60. We have, what else do we have? The height, y initial, is 3.8 meters. And we need to find A, the amount of time required for it to land, B, how far from the base of the ledge, so that's the horizontal displacement, and then C, a height at a later time. Okay, good. So starting with A, find the time required to land. Good, so this is our initial velocity vector. Then lands at a final height of 0. Notice that they didn't give us an angle theta, and they did use the phrase horizontally. So the angle of the velocity vector is 0 degrees. So here's our options, our equations, and usually we apply this equation to find time. We don't normally have final velocity given. So height final minus height initial equals VI y times t plus 1/2 gt squared. Height final is 0 when it touches the ground. Negative y initial equals VIY means VI times sine theta times t. Are there any other zeros we can plug in to simplify the equation? Well, theta is 0 degrees. We could have realized that sooner as well. Sine of 0 is 0. So the entire equation reduces to negative y initial equals 1/2 gt squared. So multiply both sides by 2. Divide by g. This is equal to t squared. Square root both sides. Negative 2 is 3.8 divided by negative 9.81. It's all equal to t. So we get 0.775. 0.775 seconds is equal to the time. Good. I don't want to get messy, but I'm going to do part B over here. Find the range of the projectile. Now, the only equation pertaining to x is x equals vi x times t, but vix means vi cosine theta. Vi is 60. Cosine of 0 degrees times 0.775. And cosine of 0 is 1. You could have saved some time if you notice that, maybe not write as much. So 60 times 0.775. That's 46.5. So the projectile moves X amount, which is about 46.5 meters. That's part B. Good. And for part C, what is the height at a specific time? C, so we use this equation as well. So height, specifically when t equals 0.600 seconds. Well, looks like we're talking about heights and times. We'll use our quadratic kinematic equation. The initial y times t plus 1/2 gt squared. Again, VIY is VI sine theta. The sine of 0 is 0. Height final 0. Oh, but yes, in this case, we don't want the ultimate height, which would be y final equals 0. We're actually solving for a y final. So there's multiple y final values, and we want the one before we land. So that would be, let's see, y final equals y initial plus 1/2 gt squared. Y initial was 3.8, g negative 9.81 times the given time squared. Good, 0.600 squared times negative 9.81 for g, divided by 2 plus 3.8, for example. So we get 2.03. 2.03 meters, which makes sense because this is less than the initial height. And as time progresses, we're getting lower and lower until we hit a y final, an ultimate y final of 0. So this is another great example of a projectile motion problem. I'd say this is the second most encountered type, other than a symmetric parabola that starts from the ground and ends on the ground. So typically we're on like a ledge or a cliff or a table. And yeah, just make sure if they don't explicitly give theta, remember that theta equals 0 degrees because of the inclination of the velocity vector. It's 0 degrees. So yeah, I hope this helps. Use this as a template to guide you through other similar problems, and good luck on all your physics. Take care. Thank you, everyone.